Hello guys, this is Rydon Academia. Today we are going to be looking at the power law of logarithm. Alright, we are still on our series on logarithm. In our previous class, we made videos on the introduction to logarithm, the addition law, as well as the subtraction law. So you can do well to look at them, okay? Now in this class, we are going to be looking at the power law of logarithm. The power law of logarithm is in two aspects, okay? When we have the power for the whole number, alright? And then we can also have the power for the base of the logarithm. And what I simply mean is this: the power for the whole number, we can have something like x squared base a, alright? Now the whole number is the one having the power. And sometimes we can also have log x base a squared. That is, the base is the one having the power. So in logarithm, when our whole number is having the power, okay, the first aspect, when our whole number is having the power, we simply take our power and multiply the entire logarithm with it, okay? So this will be having 2, alright? The power will multiply the entire logarithm, log x base a, alright? And this will be giving us 2 log x base a. Are we seeing it? So this is when our whole number has the power, alright? Now in the case where our base has the power, we take the reciprocal of the power, okay? That's 1 over the power, alright? That's the reciprocal of the power, and multiply the entire logarithm like we just did. So here we'll be taking our reciprocal, which is 1 over the power, which is 2, right? Multiplied by our logarithm, log x base a, alright? Then we'll be having 1 over 2 log x base a. So these are the two situations where we'll be having power law of logarithm, whether our whole number has the power or the base has the power, right? So now I'm going to take a brief illustration. Now let's assume we have log 8 base 2. Log 8 base 2, alright? Now log 8 base 2, if you can see this clearly, you see that we can split our 8, alright? We can break down our 8 in powers of 2. So we'll be having that as well, log 2 raised to power 3, alright? Our 8 is 2 raised to power 3 base 2. Now in this case, our whole number, which is our 2 here, is having the power, right? So we can take this 3 and multiply the entire logarithm, since it is the whole number that has the power. So we'll be having 3 times log 2 base 2, and that will be giving us 3 log 2 base 2. And I told us in our previous video that logarithm of the same base is 1, right? So this will be giving us 3 times 1, which is equal to 3, alright? That's for this. Now I'm going to take another work like illustration. Now in the case where we have, let's say we have log 9, alright? We have log 9 base 81, alright? We have log 9 base 81. Now we can split 81, right? Either to break it down to be a power of 9, or we can decide to split the both of them, alright? So now what we can do, split the both of them. 9 will become 3 raised to power 2, right? 81 will become 3 raised to power 4. Now in this case, both the whole number and the base is having the power, right? So we just apply our rule. We take the whole number, multiply the log, but we take the reciprocal of the base, okay, which is 1 over the base power, alright? So we'll be having 2 times, now the base power is 4, so we'll be having 1 over 4, right, times log 3 base 3, right? Now 2 over 4 will be giving us 1 over 2, right? 2 we cancel here, 1 cancel here, 2. So we have 1 over 2 log 3 base 3. And logarithm of the same base, like we say, is 1, okay? So that will be giving us what? 1 over 2. Okay, so this is what it means when our base or our whole number has the power, alright? Now I'm going to take an example and then let's apply what we just did, alright? Now we have log 64 base 2 plus log 2 base 4 minus log 16 base 4, alright? Now we cannot apply our addition law because here the bases are different, okay? But we can choose to apply subtraction law because we have the same base, okay? But for the emphasis of this video, we're going to be using our power laws, alright? So I'm going to be expressing 64, we'll be using their powers. So we can change 64 or reduce 64 to be 2 raised to power 6, alright? Base 2 plus this also we can change our 4. We can reduce our 4 to be 2 raised to power 2 and then we can reduce both of them in this case to be 2 raised to power 4, and for 4 we have 2 raised to power 2. Okay, so we're going to be doing what we just did. We take, since the power here is for the whole number, we'll be multiplying this logarithm by 6, alright, plus this we're multiplying by the base power, which is the inverse, right? So we'll be having 1 over 2 times log 2 base 2. And then for this case, we're having two situations. So we'll be taking both for the whole number's power, which is 4, then multiply by the inverse, alright? The inverse of our base power. Then we have log 2 base 2. Alright, let me keep them in bracket. Alright, so from this we're having 6 log 2 base 2, right? Plus here we're having 1 over 2 log 2 base 2. And we're having, this will be giving us 2, and here will be giving us 1, right? So we are left with 2 log 2 base 2, right? Now, logarithm of the same base, like we say, is what? 1, okay? So this will be 6 times 1. This will be 1 over 2 times 1, and this will be minus 2 times 1, right? So we are left with 6 plus 1 over 2 minus 2. Do you see how easy it is? So you can choose to use your LCM method, or you can choose to solve directly, okay? So we'll be having 6 plus 1 over 2 will be giving us 6.5, right? And then minus 2, we are left with 4 whole number 1 over 2. Alright? So this is our answer when we solve all these things using this method, right? Now I'm going to take our second example. Alright, so for our second example, minus log, okay, minus 2 log 5 over 9 plus log 480 over 243. Alright, so this is what we're going to be using for our next example. Now, if you can look at this very well, you can see that there is no base given, right? There is no base given. So whenever we are giving a logarithm without base, without a given base, we assume that that logarithm is in base 10, okay? Whenever we are giving a logarithm and there is no base given, we assume that it is in base 10, right? So they are all in base 10 right now, as you can see there, but all don't have bases. So they are all in base 10. But before we continue solving, I want to take these 2 back, alright? This is why we are having a power law. So we are going to be taking these 2 back, the same way we brought it here from the power, right, of the whole number. So we'll be taking it back to make it a power of our whole number again, okay? So we'll be having log 30 over 16 minus log 5 over 9, and then the power is coming back, alright, plus log 480 over 243. Alright, we have log 30 over 16. Now, in expanding or in opening our bracket, we'll be taking the square of both the numerator and the denominator, okay? So we'll be having log 5 squares 25 and 9 squares 81, alright? Then plus log 480 over 243, 243. Alright, now we can apply, since they are all in one base, okay, like I said, it's in base 10, right? Now we can apply our subtraction law and our addition law, okay? So our subtraction law holds for division. So we'll be having 30 over 16 divided by 25 over 81, right? And then multiplied by 480 over 243. Right? Now in dividing fractions, we can take the inverse, okay, or the reciprocal, and then change our division sign to multiplication. So we'll be having log 30 over 16 multiplied by the inverse, which is 81 over 25, and then multiplied by 480 over 243. So what we are going to do now, we are going to simply multiply all the numerators together, right? So we'll be multiplying 30 by 81 and then times 480. Alright, so we'll be having 1 million. I'll be giving us 1,166,400. Now for our denominator, we'll be having 16 times 25 times 243. Okay, that's going to give us 97,200. So we are going to divide this, okay? So we'll be having 1,166,400 divided by 97,200. Alright, and we are going to be having 12. Okay, so you can either leave it as log 12 like this, or if you want you can bring in your base 10 if you want, or even if you leave like that. But like I said, whenever a base is not given, we assume that it is in base 10. So with this, we have come to the end of today's section on the power law of logarithm. Subscribe to our channel if you have not. View our videos, turn on your notification button, and then share our video with as many as you can. See you in our next class. Thank you.